Hello everyone, in this video I will explain you my end semester data science paper solutions. So this is my end semester test solutions. So first question is with reference of life cycle of data science project. Complete the following table of life cycle of data. So here's a complete table of for a data science project life cycle. So the first stage is define a problem. Like in this stage, we have to define a problem, like identify business objectives and goals, understand stakeholder needs and expectations, etc. And the description is, this stage lies the groundwork for the entire project. So it's crucial to clearly define the problem you are trying to solve and how a data driven approach can contribute to the business goals. Then second is data collections. In this phase we have to identify relevant data sources like internal, external, structured, unstructured. Establish data acquisition methods like APIs, scraping, databases, surveys, experiments, address data access and security. So the description is, data collection involves finding and gathering the data necessary to analyze the problem. Ensure that the data is relevant, accessible, and adherence to ethical practices. Then we have data exploration and pre-processing. So it's explore the initial data to understand its characteristics, distribution, outliners, missing values. Perform data cleaning and pre-processing tasks like handling missing values, outliners, normalization, feature, scaling. Analyze the data relationships using visualization techniques. Identify potential patterns and insights. Then this stage delves deeper into the data. You will clean and prepare the data for analysis, ensuring it's well suited for modeling, and the goal is to transform raw data into a high quality usable format. Then we have feature engineering. To create a new feature from existing ones to improve model performance, select or combine existing features based on domain knowledge and statistical analysis. Apply feature selection techniques to reduce dimensionality if necessary. Consider techniques like encoding categorical features, scaling numerical features, and handling non-linearities. The description is true, though feature engineering, you craft new features that might be more informative than the originals. This step can significantly enhance model performance. Then we have model selection and build. Choose appropriate machine learning algorithm based on problem type like classification, regression, clustering, etc. Consider the factors like model complexity, interpretability, and computational efficiency. Split data into training, validation, and if possible, testing sets. Train the models on the training set, optimizing hyperparameters. Like this sets involves selecting and building the model that we will analyze the data, and different algorithms are suited for different types of problems. Then we have model evaluation. So evaluate model performance on the validation set using appropriate matrices like accuracy, precision, recall, F1 score, AUC, ROC, etc., and compare the performance of different models, considering both the accuracy and interpretability. Identify potential biases or limitations of the model. fine tune hyperparameters, or iterate through different models based on evaluation results. Um, in this, we have evaluation helps you assess how well the model generalizes to unseen data. It's crucial to go beyond just accuracy and consider other relevant matrices. Then we have model deployment. So integrate the chosen model into a production environment like web application, API, batch processing system. Consider real time or batch processing requirements. Version control the model and code for reproducibility, address potential scaling needs and infrastructure considerations. Model deployment involves making your model operational so it can generate insights on new data, and this stage ensures that model can reliably answer real world questions. Then we have model maintenance, monitoring and maintenance. So monitor model performance over time to detect degradation or changes in data distribution. Consider strategies for addressing model drift like retaining, recalibration, implement logging to track model behavior and potential errors. Schedule regular evaluations and updates to maintain model effectiveness. Like monitoring and maintenance ensure the model continues to provide accurate and valuable insights. Regular checks are essential to catch potential issues early. Then we have communication and reporting. So communicate project findings to stakeholders in a clear, concise and actionable manner. Create a reports and visualizations. Then we have data science project lifecycle, tools and libraries. Like for defining a problem, we have these tools. For data collection, we have Scrappy, SQL Alchemy, um, like this. For data exploration and pre-processing, we have NumPy Matplot library. For feature engineering, we have Skikit. For model selection and building, we have TensorFlow. We have for model evaluation, we have accuracy, precision, recall, F1 score. For model deployment, we have job library, MLflow, TensorFlow. For monitoring and maintenance, we have Datadog. For communication and reporting, we have Matplot library, Cbon. Then explain the role of text mining in automating grievance redressal system. List the key steps involved in pre-processing unstructured text data. So text mining is automating the grievance redressal system. Text mining a subfield of data mining. It's a subfield of data mining. Plays a crucial role in automating grievance redressal system. Then key roles of text mining in grievance redressal, like automatic categorization. Then we have sentiment analysis. Then we have topic modeling, named entity recognition. Then these are key steps in pre-processing unstructured text data, like tokenization. So it's a breakdown of text into individual word or phrases. Like this. These are examples. Then extraction. So identify relevant information and entities. Then topic modeling, identifying underlying topics and themes. Then entity recognition, so identifying named entities. Then we have relationship extraction, like identifying relationships between entities. We have classifications, like classify the text into applicable BNS section or IPC section. Explain the concept. Then our next question is explain the concept of linear regression and how the best fit line is determined. Write the algorithm for linear regression for giving input data points x and y. So linear regression is a statistical method used to build to model relationship between dependent variable y and one or more independent variable x. So it assumes a linear relationship between the variables, meaning that as the value of x changes, the value of y changes proportionally. So the best fit line is determined by using the method of least square, and this is the formula for determining the best fit line, where n is slope, b is intercept, and this the algorithm of linear regression is first calculate the mean of x and y, then calculate the deviation of x and y, then product of deviation, then sum of product of deviation, then calculate the square of deviation of x, then calculate slope. The formula of slope is this, sum of, then intercept, the formula of intercept is this. Then write an algorithm to create two clusters and write output of the each round. So initialize centroids. First we have to initialize centroids. Here we initialize the centroids, then assign the data points to the cluster. Now round 1 we assign the data points in this cluster, then new c1 is this, new c2 is this. Then round 2, since the cluster assigned we have not changed, the algorithm converges the final cluster are this. Then we have explained the key differences between k-means clustering and hierarchical clustering algorithms, and what are the advantages of hierarchical clustering over the k-means when visualizing cluster relationships. So these are k-means clustering, these are k-means clustering. Like partitioning method, divide the data into predefined number of non-overlapping clusters, then centroid based, then iterative process are this, then recompute centroid based on assigned data points. Then advantages are efficient for large data sets, relatively simpler to implement. Disadvantages may not handle non-convex clusters well. Then we have hierarchical clustering. So hierarchical method creates a hierarchy of clusters starting from the individual data points and merging them into a larger clusters. Then these have two main approaches: agglomerative hierarchical clustering and divisive hierarchical clustering. The advantages are does not require the number of cluster to be specified beforehand, and the disadvantages are sensitive to noise and outliers. Then dendrogram, a hierarchical cluster. Examples are dendrogram. Then classify loan application by assigning applications to one of the three risk classes. Use entropy or information gain approach, a Gini index approach. So approach 1 is in entropy and information gain. So first of all, calculate entropy. So the formula for calculating entropy is this. Then compute information gain. So the formula for computing information gain is this. Then choose the best attribute. So select the attribute with a higher information gain for splitting the node. because the attribute which have higher information gain is the attribute which provide a more information about the data. Then recursive splitting. Then second approach is Gini index. So we have to calculate the Gini index, then compute Gini gain, then choose the best attribute, select attribute with a then example. These are the then example step by step example. Here we take us example and a Python solution, Python code also. Thank you. That's all for the today's video.